Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Farhan, and me and my group 9, would like to present about the topic that we get. The question that we get is question 6. But first, we meet our group. So now we go to the introduction. Mathematics is now essential in our daily life, as it is used in various tasks such as managing budgets and cooking. Neglecting math can lead to difficulties and many serious problems. So in this scenario, our group has been assigned to calculate the cost of the cheapest 1000 cm3 cylinder tin, taking into account the different costs of the material used. So now we go to the next part.
Alright, now the minutes meeting. We make a meeting and on 9 January 2024, the time is 8 PM till 12:30 PM in study room at A12B 506. So the attendance is all of us, which is Adib Afnan, Muhammad Ainal Yakin, Nabil Hakim Fazli, and then Muhammad Danish Fahan. So the activity is our leader Danish Fahan divide the job scope. So Adib Afnan take the problem and solution, Muhammad Ainal Yakin take the discussion and conclusion, me Nabil Hakim Fazli I do the fila table and minute meeting. So our leader Muhammad Danish Fahan make a table content and introduction. So second one, we discuss for the fila table content, and the third one is we find the solution for the problem. And the last one, we find the related results about the can productions. I'll tell you more about filler table and detail. So the question A, we assume that only cost for the material is the cylinder. So the material for the top and bottom cost 50 cent per cm square, and for the side is 30 cent per cm square. How much is the cheapest is the question that we asked for ourselves, and we need to find the height, the head and the radius of the least expensive cloth cylinder, which has a volume of 1000 cm3. Okay, firstly I will tell you about the facts. The first fact is the only cost for the cylinder is the cost of materials. The second one is material for the top and bottom cost 50 cent per cm square. And for the third fact is the material for the sides cost 30 second per cm square. Now let's move on to the idea. So the first one is the cylinder is the only shape that we have. The second idea is the top and bottom costs are more expensive than the sides. The third idea is side thickness is thin. The fourth idea is top and bottom thickness is thick. The fifth idea is top and bottom are more rigid and durable. The sixth is aluminium is cheaper and more effective for can production for beverages. Okay, after I explain about the idea, now we will move to the learning issues. So at the learning issues, I put 5 questions that I got for the topic that we have been assigned to. The first one is I put the question about what is the material, what material is suitable for can production. The second one is why are top and bottom materials is more expensive than the side materials. The third one is thick or thin material is more suitable. The fourth one is does the cylinder have high durability. And the fifth one is the question that I put for the construction, under what circumstance can we use can. So there you go, the last part of the filler table. So the action plan. The action plan is we put a questionnaire about the cans production. The second one, we seek all of the information about cans through the internet. The third one is we understand the problem and we make a literature study about cans production. Four of us, we discuss the question and we solve the questions and get the answer.
Hello, my name is Ali Afnan. So right now I'm going to talk about a problem and solution. The engineering project we are working on requires us to create a 1000 cm cube cylindrical tin at a reasonable price. The material used to build this tin will cost different amounts for each section. For example, we'll be using 50 cents per centimeter square will be spent on the top, and for the bottom it will be spent for 30 cents per centimeter square on the side. The main objective is to build the tin as cheaply as possible without sacrificing the required volume. So the problem is cost optimization for constructing a 1000 cm cube cylinder tin. And the solution is, from the top we use the V equal to 1000 centimeter cube, and we just put number inside, and then we got 3500 over 11 equal to R square H. So let H equal to 10, and we got R as equal to 5.641. So the top we set the R into the formula, and we got 100 multiplied by 0.5, and from the top we got only Rm 50. For the bottom we use the formula 2 pi RH. So you calculate, you got 354.577 multiplied by 0.3, and we got 106 and 373. And you measure for the bottom. So for the total we got is 50 plus 106 and 36. So we got top and bottom for a total of 156.37. So that's all. Thank you.
Today I will talk about our discussion and conclusion. For our discussion, first of all, we will talk about material characteristic. The top and bottom part of the can are made material like aluminium or tin plate to create a strong seal to keep the content fresh. This component play a crucial role in preserving the integrity and freshness of the content. The side of can mainly focus on protecting and keeping the structure intact. While the body of the can does not require the same level of sealing, it still needs to be durable and resistant to weather condition. As a result, cheaper material like plain steel or aluminium are commonly used. The second one is production procedure. To create a secure seal, the manufacturing of the can ends involve intricate process that involves precise engineering, shaping, and special coating. This procedure can contribute to the overall cost of the can ends. First, this shape of usually cylindrical will simplify of manufacturing process and reducing cost. The last one is functional requirement. To prevent the content from damage, the top and bottom of the can must effectively block moisture and the air. This requires high quality sealing material which may be more costly and specialized. The main purpose of the can body is to hold the protect its content, while the material requirement of the body may not be stringent as those for the ends, it still need have sufficient strength. In conclusion, the use of can cannot only be used in the field of food, but it can also be used in the field of construction. We also use the thick material because it's more have advantages than the thin material. We believe that can which has a 5.461 cm radius and 10 cm height is the least expensive closed cylinder that has a volume of 1000 cm cube.